The recording. All right. So first we have to learn about the matrix operations in our last week class. So we learned about the addition, which you can do the plus and minus, right? We learned about the scale, which you can apply a number outside of the matrix to inside of matrix. That can be either multiple or divide, right? And we learned about the transpose of a matrix. And also we learned about how to find the determinant. And also we are kind of like the understanding this identity matrix, which is I for the diagonal for the other elements is r equal to 0, right? And also with define the determinants, with understanding the identities, and we are able to find what is the inverse of a matrix. So in this class today, we will continue learning the matrix operation. Instead of a 100 calculation, we will do with the Excel first, and then we will move into the MATLAB, right? First of all, you see in this PowerPoint slides, we can likely see kind of the comments over here. See MULT. So we just put in here in case we forgot what it means, right? And then we have the transpose. Uh, so you guys can open the Excel and to work with me in the meantime, right? And also we have the mid term. So and also the matrix invert. VERSE. So how to use those things? Since we know the Excel is kind of likely a column and a spread and it's a spreadsheet with the rows one as a number and also with a column A, B, C, D, E. This is kind of more likely like our matrix. So if we want to define a matrix over here, we can type in 3 by 3 matrix over here in case we want to use this one. So you can give a so we can put in 1, 2, 3, 1, 2, 3. So just in case that is not exactly, you can type in the different numbers here, right? So I put a one more here. So actually we don't need this one. We can delete this one. So this is more likely a 3 by 3 matrix. Here we have the 3 rows. The first row is 1, 2, 3. Second row is 1, 2, 3. And the third row is 2, 3, 4, right? And also we have 3 columns. The first column here is 1, 1, 2. Second column is 2, 2, 3. And then third column is 3, 3, 4. So this is kind of like the things we practice with the handwriting, right? So now we will learn how to using those input here as a matrix. And also, if we want to make it, much more clearly or a good view about this one, what we can do is we can put we call that is the, let me squish a little bit of here. So we were using the, the left border and also the right border for this one, right? To make it more likely a matrix. And definitely I can remove the color here. We don't need to have the filling here. So we can definitely to increase this styles over here, we can put in where's the size of thickness, right? We want to do a thickness line here. So we can get it more here, right? So from this one to this one. So you have a much more better. So that is clean by more board option. So if you same as me using the Mac over here, you will see this option. And we pick up this is our last there, and we will go to this right one here, right? So kind of like you getting idea about this is more clearly, this is your matrix here. The other way you can do is you just give it a slight color here and make sure you understand this is a matrix. So Okay, so this is first thing we were dealing with Excel. We needed to how to define our matrix here. For here we have a 3 by 3 matrix. Right. So okay, it's 3 by 3. So okay, we're moving to the next slide here. So Excel matrix. Here is the something we did it before, and we're trying to putting this together, right? So repeat the previous problem. We have this one. This is 2 by 4, and then we have a 4 by 3, correct? So we can type in those two metrics here. So 3. And another thing you can do is you definitely can want to make this matrix more compact, right? I mean, in the horizontal direction. So what you can do is you can highlight all those from here and just to squish a little bit more, right? So this is much more better. So we can type in those. This is too tiny or too narrow. Then we can give a little bit more. All you can do is, or you can select all those, right, and do the adjustment here. So the way I really want to do is, if you highlight over here, then you will do applying to all those columns and also apply to all those rows. So you can do such of that way to easily use it. So we can type in, and another thing is we see all those numbers is in the central. So we want to do this. So if we want to apply to all, we can do this. And we click alignment here and we in the center, right? But for those things, we can likely want to keep it as starting from the left, right, align to the left. So we can type in 3, 5, 1, and 0, and we can type in 2, -2, 1, and -1. So this is our first matrix here, which is 2 by 4 matrix here. And then we have the second one here is 2, 3, 1, and then 0, 1, 0, -1, 2, 5, and 2, 2, 1. So you don't need to put in the same column with me, I mean the row number here or the column number here. So if you are different to me, the only thing you will be do different is when we're trying to select the matrix, we will select a different one. Okay, so it doesn't matter, really need to be aligned with this one. So this is a 4 by 3 matrix. So if you have any question, you can just pump up and let me know. You can unmute yourself and asking your question. If you want to more time, just let me know. So so far so good here. So just type in the first two matrices over here, and one is 2 by 4, and another one is 4 by 3. Okay, if you're done with this one, we'll move to the next slides for the next comments we're going to apply to here. So once you define that one, if you want to give a little bit more clearly what is it, you can do is you can select those two, and you can right click this one, and because you want to combine those two together, right? But if you see my over here is the combined information is not pump up or the camera is not come, you can going back to here, right? So select those two, and you will see the combine is here. So you are measuring the two together. You can measure at the center, and then we can type in A is equal to this one. So if that is not center in the middle, then you can click that one, which is middle aligned, right? And also we can do for this one. So we can click the measuring the cell. So measuring cross center. I think that is basically the same way. It's a different alignment. So you can try different ones. And also we do center this one. Now we have defined this one. And the next step we'll do is trying to give its board. So so we can do this one. So pick up the board one and apply to the left. And the same thing for this one, right? So it's not pump up, then we go to more board option and pick out that one, do it again, and then do this one. Oh, the another way you can do is you just want to, if you have this one here, and you're going to do that one, and pick up this, and okay, so you can copy this one. You can copy the format here, and then you can paste over there. See, it works, right? So you can do this. So if you already defined this one, if you want to apply to here, so just select this one and click this brush over here, which is copy the format, right? And then you can apply to here. So any questions so far? All right, if not, we move into the next one. So next one basically is doing the same thing over here. We already have this one. You can definitely change the color to match the one we want to show in here. Right? Or what other color you prefer. So you can give it a different colors. It's not really a good deal. Okay. So the sense we did not show on this slides over here is about the matrix dimensions over here. I would like you to have this one because it's more directly you will see, yes, this is my matrix and that is different, right? So, all right, so once we deal this one, we are going to the next slides. So the next one here is more likely we want to do the multiplication, right? So if we do the multiplication first, we will determine whether those two matrices compatible. The compatible means um, the column number of the A will be equal to the row number of the B, right? And you will compare this. If I have a pen over here, I can do this. So you will compare this four and those four if they are the same, right? So if those are the same, and then your final results for your C will be determined by these two and these three. So you will get a 2 by 3 matrix for your C. Right? So if you are understanding your results will be a 2 by 3 matrix, what you can do is you can first you will determine, I'm going to accept from my drawing here. I'm going to exclude out my drawing. Okay. So I'm going to select this one over here. So anyone you prefer, you can do here or here is doesn't really big deal. I want to do here. So this is a 2 by 3, right? 2 rows and 3 columns. And then you're going back to here, you're putting some color here to let me know this is what do we call it? 2 by 3 matrix here. And this is matrix is going to be the C. So you can do the imagine this together, C, right? So definitely you want to do alignment, you can put it in here. So same way, if you want to do the board about this one, you can go to the more board information over here and pick up that one and do over here and repeat this one again. So I want to use in the color, I can do this. I do the color. But the color is different, I'm easily to change the color. Okay, so I got this one. So you are using A to the matrix A to multiple with matrix B. And again, here, you understanding here that this should be a board one because this is a matrix, right? So this one, the results for this one will be equal to the C. And the C is a matrix, should be 2 rows and 3 columns, right? So once we prepared with this one, so we are good to apply this one over here to getting the results, right? So let's see how it works. So you are typing here is equal to first, we type in the equal here because we want to see this is operations over here with the Excel. So M is to activate the matrix, and MULT is to activate the function of the multiplication, right? So we give them a block over here. So it will asking you, you are typing the first arrow over here. So first we selecting this one. And then using the comma to separate, and we finding the second one over here. Okay, once we done, we can give a close brackets over here, and then we enter. We're getting the results for this one. You guys all get the same number. If you have the different number, please let me know.
Can you
So
show
don't.
what we type in again?
Okay, good. So I'm going to uh delete those again. Okay. So it's equal to MULT, right? Once you type in this one, and it will be pump up the information here, make arrow 1 and arrow 2. Arrow 1 is A, which is a matrix A. So you don't need to put in this B3, E4 because we are different locations than this one, right? We just select that. So once you're selecting the A, then you give a comma, then you're selecting B. And then you're ending with it. So I'll copy this one out, but please do not directly type in this one, just using what we call selecting, right? So, and this is good to the left side. Yep. Are good with this?
Yes, thank you.
Yeah, good, good. Yeah, and then moving to the next one. So, for here is more likely give you where's the range, where's the cell. So you will select them. And you can use an enter key with the arrow commands only return answer in each cell. We already get this one, right? So this is an answer same way, and we try to format. Okay, the next one we are going to do is more likely continue with this one with transpose. So it's quite simple. You guys want to try by yourself first? Or we can work in together, right? So we're going to here is some of the here you can do the same way, or we can directly use any of those we want to do, right? For example, we want to transpose this C, right? We're getting a C prime. So the C prime, as we said, this is what we're going to in the MATLAB we are using C prime, right? But in most cases we were using the case is called C and a T sign over here, right? And this T will be a up case here. See if we can do. We have a challenge here to getting the up transcript in the Excel over here, but we can easily getting this one in the what do we call the Word, right? Yeah, I did not see anything we can do. And if I do this, we'll be going to lowercase. So I mean, I just keep using this transpose here, but we know this is a transpose, right? Okay. And we understand this is a transpose. All right, so how can we get a C transpose? So we can copy this one if you want. If you want, we can do like in this way. We put in here, and you see it's already being copied and cut back, right? So we give a prime here, so we understand this is C transpose. On the C transpose, you know, so this one, this C here is 2 by 3, and we do the transpose, we are getting a 3 by 2, right? Because we want to switch the column, switch the row, so C will be a 3 by 2. 3 by 2 is more likely, we need one more here, so this is not a big deal, but we need one more, so we do this way. So then the result will be showing like in here. So we can type in here. So first we determine it's 3 by 2. And we select the 3 rows, 2 columns. And we can give a little bit of color over here and indicate this is our matrix here. And you come back to the first one over here. So, and you type in transpose TRANS POSE, right? When you're hacking, you will see this one. And then you select this area, right? So you will select this C because we're going to transpose this one. Then you're getting 568 from the first row to the first column, and 146 and then come to the second column, right? You all got this one? So if you go into hiding this arrow here, you will see this has a small sending blue boundary over here to indicate this is a matrix, right? So hitting any one of those. So I'm going to copy this color here. I'm going to copy this color here. And I want to change this color back because I want to see this is different, right? So you're getting your C, and this is your C prime. So this is example shown on this slide is the same way, but we want to save our time. We don't want to type in this one. You will see this 10, 12, 1, 2 is switched to the first row. And definitely we can deal with a B prime over here, right? So let's see what we get. So we can deal with this one, A prime. So, okay. So we want to define A prime. So we can second this one. So we see A is 2 by 4, and then the result will be more likely 4 by 2, right? So A prime. A prime will be 4 by 2. So since we know 4 by 2 is 4 rows, 2 columns, right? Then we assign a color here. We can definitely copy this here, and then we can copy that one to here. So we're getting our A column, our A prime here is equal to, and then you want to center this one. Okay, so this is equal to TRANSPOSE, right? And then you select A. Enter. Then we're getting 3510, 3510, right? And this one coming to here. So you can do the same for the B prime. So B prime will be going to a 3 by 4. 3 rows, okay, 3 rows and 4 columns. So, okay, got in this one, copy this one down to here, and definitely want to copy this one. Okay, so the color we can change it to a little bit of light gray over here. So similarly, you can imagine this one and centralize this one and putting a B prime here is equal to. So equal to TR. So once you type in TR, you will see this transpose, just hide it. And then you see I had anyone is fine. This will be directly changed. I'm going to select this B here, right? And enter, and you will see 231 is coming to here. 010 is coming here. The set row one, -125 is coming to the set column, and then the first row coming to this first column. So far, so good. So just let me know this is a matrix. Okay. So this is our matrix transpose, and it's pretty easy, right? So the next one we're going to do is the matrix determinate, right? So determinate. So let's see. So the matrix determinant is still the easy way because we are studying the matrix determinant exactly a number, right? So we only need to use a single cell in this Excel, which we mean that one. So what we can do is we can find in the A determine, we can find in the B determine, we can find in the C determine, okay? So you can type in here or a way if you want to. Because I have a tiny space over here, I just putting it here, okay? DET, which is DETA is equal to Just type in here, let us know this is your determinant, right? So is equal to, so when we type in, you are typing is equal to matrix and determine, right? It's starting with M and then DET, you see this one. So now you're going to pick up your arrows. So my arrows for first one is from A, so we pick up that one. Okay, so interesting. When I do this one here, it does not return a number. I'm determining and this here. Interesting. So let's try B here is equal to matrix determine. Not that one, and this one. It's no value. What happened to here? Do you guys have the value, or you same with me is no value, or return to the arrow to you?
It's saying the same thing for me.
Is the same thing to you?
Yeah.
That's interesting. Oh, hold on. Yes. Not every single matrix has its determinant. So if we review back, we'll see only those matrices with the same dimensions will have the determinants, right? So let's come back here. So let's come back to here. So the determinant of a square matrix is a scale quantity that has some use in the metric algebras, right? So we only can find in those square matrix, which is 2 by 2, 3 by 3, and 4 by 4. But if we can find the determinants for the row and the column number is not equal, then we cannot find the determinants. Okay, does that make sense? So we tried that one and we reinforced that we learned not all those metrics can have its determinant, and only those square metrics can have the determinants, right? So for here, we are here. So right. So for those A here, this is no determinants, right? That is because A is not a square matrix, right? So okay, and also for here, B is not square matrix. For here, this one, I only pick up the C here, but if I pick up the whole set, it will be written the same way. But if I did not pick up all those, I just pick up those four here, you see you will have the results, right? So uh, just a quick remind over here. So for square matrix, only, right? Okay, so let's see what we can testing with this one. So we're going to define a new matrix called A. No, this is doing with Excel. We are still working on the Excel, and then we were using the MATLAB. So the MATLAB is MLX. So I do not provide any download lab script for the MATLAB on the canvas yet because we're supposed to doing those together. Okay. So we're doing another A matrix over here, which is equal to squish those a little bit. We're doing our A matrix over here, which is 2, 5, 6, and a negative 1, 0, 5, and then we're getting 3, 2, 2, right? So this is our matrix So I want to save my time. I just want to copy this color over here and quickly finish this one. Copy that one here. So if you have a question, just speak, unmute yourself and speak directly. I may not able to catch the chat. Okay, so now you define your matrix, a new A here, which is a 3 by 3 matrix. And with this 3 by 3 matrix, you will be able to use to find its determinant, right? So det A, which is determined, is equal to M determined, and we pick up this in here. Now we got it. It's 53. So question so far? Okay, I suppose you are all following very well, and we're moving to the next one, which is going to find out our inverse, right? So we already finished the 1, 2, 3 here. Now we jump into the first one. Again, so it's only the square matrix can have its inverse. That is because only the square matrix has its determinant, right? So if we're going to keep using the A here, we will finding our A inverse, which you can do is a negative one, but most likely we will type in this way inverse, right? So this is equal to something over here because it's 3 by 3 as well. Remember, the equation for the inverse is using 1 divided by its determinant and times with another matrix, right? But for 3 by 3, we do not know the equation, but for 2 by 2, we know the equation is switch a little bit, right? Switch the diagonal, right? And then put a negative sign for those diagonal. So this should be a 3 by 3 matrix. So we can copy this one here. So because when you're doing the copy in the Excel, you exactly copy the formats as well as the numbers. Now we're going to clean the numbers, right? So select M and delete. You will clean the numbers. Okay, so you can delay one by one as well. So if you use a Mac, so this is a delay on the table, you click that one. But if you using the Windows, and then you are finding the delay, don't using the backspace, using the delay. Okay, now we're going to type in our equation over here. So this A involves, first we need to make sure this is a matrix. So push this one a little bit to the left. So okay, so it's equal to M in IN VERSE. Because this one, you see, if you type in MIN, then you have medium, then you are typing more to figure out what is the M inverse. So arrow. So you have the arrow here, so you will select the A here and type in. Then you're getting the A inverse is like this way. Okay. So because if you look in the result over here, it has more decimal place. So what we do is we will select this one and right click it, and you will see they have a cell format, right? Format cell. And then you go to the numbers, you go click the numbers, and then we give it more decimal place, right? And then we have this one, exactly the same thing. Uh, change the color a little bit to see more clearly. And so far so good. And John, can you mark the attendance for those who are attending today?
Yes, I will do that. Thank you.
Yeah, thank you. Mhm. All right. Any questions so far? So
No.
is that okay? No question, right? So definitely you can save this one to okay, so save this one to your computer. I have a bunch of over here. Save this one and putting the name for this one is more likely what do we say? Why this pop up? Okay, save this one to your computer. Going to my whatever you want, right? And type in this one is in class, which is November 24th, and Excel. Okay, so save this one. Save this one first, and we will not submit yet. So just save this one. Okay, so once we figure out this one, A and A inverse, and we understanding A multiple with A inverse will be equal to identity. And also in the meantime, we can calculate the determinant for A inverse, right? So that's what be equal to just practice and determine, right? And pick up this arrow and getting a very, very small number over here. So got this one here. Okay. So the next one we're going to figure out is the A times with A inverse should be equal to I, which is the identity matrix, right? So we can do, since I do not have enough space here, I'm going to move this one to here a little bit. Okay. So when you see this sign over here, it means you don't have enough space. What you can do is you can double click over here will automatic adjustments, but I don't want to do this. I want to squish it a bit. Okay. And for this one, is not exactly equal to 0.019. It has a decimal place, and we just leave it here. It's fine. So now we're going to define our A matrix times with A inverse, right? This is equal to something. So should be a 3 by 3 as well because we have three. We have same 3 and 3 here. Then they are compatible. And then we have those 3 and those 3 here. That means the results will be a 3 by 3 one. So we will have just appreciate a bit more here, and we are going to have a 3 by 3. Okay, 3 by 3. So if you know it's 3 by 3, and then we can do the same thing again. We copy and then we release this one. Just give another color here. It's not necessary. I'm just in case you want to see it clearly. Right? 3 by 3, and then we can type in here. This is 3 by 3 matrix over here. So what we do is just using select the first cell over here is equal to M multiple, right? M, and you will see M multiple here, and the first one, and the comma, and pick up the second one. And enter, and you will see here is 1, 1, 1, and those is negative 0 is still 0. So I don't know why this negative 0 comes out, but it's interesting. Okay, so okay, I see the way I'm here is wrong is maybe because I did not select this one. Oh, we try again, and then this is equal to mm. We pick up that one, and then we pick up that one. Interesting. So when you say I do this one, is more likely it's a matrix. So using, I pick up the first one, then it's referred to the matrix already. Okay, so y'all get the same number with me? Are good so far? With the actually four methods over here we learned is multiplication, transpose, determinate, and also the inverse. Right? Are good? We are good. We can have a 5 minutes break over here since we almost spent a 15 or 45. Actually, we starting it's 5 minutes delay. So we can have a break and then we come back. We should be starting with our MATLAB. Okay, have a break. Recording. Okay, we just finished the matrix operations with Excel commands, and now let's take a look how to use the MATLAB to do it, right? So it's pretty the same way as Excel, but when we type in or creating a matrix in MATLAB will be different. So I'm using the MATLAB online over here, and if you just open it, you will see this is a comments window. We can do all the inputs over here. We'll be giving up a result, but more likely we can create either a script or create a level script. So the difference between the two is the script is more uh, use them for when you have a multiple line of the codes you want to running and generate results by the end. But if you want to see your intermediate results, you are creating the new library script. Okay, we can click the new library script over here, and we can start into dealing with it, right? Okay, so we're going to learn the multiplication, transpose, determinate, and inverse again. So first, we will know how to create a matrix. So when we're going to create a matrix, we are using a space and the comments, right? Normally, we're only using space over here to separate the elements in a row. And then we're using a semicolon here to separate the matrix in the column. So we can type in here. For here is these two blocks over here, or the left arrow sign, right arrow sign over here is to indicate this is in the comments here. You'll see this exactly the same thing. So we can do here is this G is equal to using this block over here, 2 space 5 space 8 space semicolon and -1 space 9 and 10 semicolon space 3 1 and 2 and so this is our matrix we can define. This is a 3 by 3 and 3 by 3 matrix here, or arrow here, right? ARAY arrow here in the MATLAB. So we can copy this one to the comments here, and you put in enter, and you will see the results is actually showing the same as the slash over here, right? So another thing we can do is we can try to using the matrix here using comma instead of the space. We can do 2 comma 8 -1 comma 9 then 10 3 comma 1 then comma 2. It should be the same way. We can copy this one and paste over here, and you see exactly the same thing. Okay, so we can either use in comma, but you want to save your time, you just using the space on the right. So this is an RTU message we can type in with Our two methods to create a matrix using uh, a comma to separate the elements in the row, right? So just quick some information over here. All right, so we understand how to create a matrix here. Okay. So if you are using the what do we call the MATLAB online and with the cat palettes, the AI is already generated something for you, and you can try accept those things, right? And you will be fine with this, right? So next one, we will do some operations. The first operation we're going to learn is called the multiplication, right? So if we want to do the multiplication, we want to creating another matrix, which is H here is equal to 4, 5 in the first row, and the 6, 12 in the second row, and then 1 and 1 in the third row. And this is uh, how many rows we have? We have 3 rows, and how many columns we have is 2 column here. It's a 3 by 2 matrix, right? So is that compatible? So you have the matrix G is 3 column, and matrix H has 3 rows. 3 3 the same thing, and then if we do uh, G times H, the results will be a 3 2 matrix, right? Is that correct? So let's try. You have your so we can copy this one coming down here, and we get a G matrix, HM matrix, and then we will have the L is the multiple of the G times H. So for this over here is exactly using this multiple sign is the same way, right? We can type this one. L times H. Sorry, L is equal to G times H. And then you see the results over here is the same as here. So the sense you are going to submit, you can have this one, right? And you right click this one, you are going to run this section, right? But I will keep using this one is because I want to uh, have the result immediately. You can definitely can run this section, and you will have your result show in the window over here. Okay, so this is more likely you're going to screenshot for this one and submit is more clearly. Okay, so far so good. Okay, so this is a multiplication, and we know we needed to testing and to understanding whether the two matrices are compatible. So if I have a matrix H, which is 3 by 2 times with matrix H, can we get a results? No, because the model will let you know the number of the column in the first matrix matches with the number of the rows in the second matrix, right? We needed to check that. So it doesn't match, then we'll not return the result to you. So we can repeat the example we had in our Excel and see what results we can get, right? So in this labeling one, you can edit the one, we can see the text. So repeat. Example. And then we switch back, we will click the codes, right? So we have A is equal to, don't see that one. Just do it by yourself. A is equal to 3, 5, 1, 0 for the first row, and the semicolon to define our second row, 2, -2, 1, and the -1. And B is equal to, we have 4 rows, 3 columns, right? First row is 2, 3, 1, semicolon, 0, 1, 0, semicolon, and the -1, 2, 5 for the third row, semicolon, and the fourth row is 2, 2, 1. Okay, so we're getting A times B is equal, C is equal to A times B. Let's try to run this section. Run this section. And we're getting A here. We're getting B here. We're getting C here. So it's 2 rows and it's 4 columns. It's 1, 2, 3, 4, 3 columns, right? So we're getting a 2 by 3. So this is 2 by 3, and this is 3 by 4 by 3. No, 2 by 4, and this is 4 row, 2, 3 columns, and then we're getting C should be 2 by 3. Are getting the same thing, right? 5, 16, 18, 1, 4, 6. Question so far? We have 1 student dropped. Interesting. All right, so this is an easy one. We will do the multiplication, which is using the same as a times sign over here, which is star sign as well. So let's keep moving to the next one. So next one, we are using the transpose. So the transpose is very easy. So it's A prime and the B prime and the C prime, and you will see the results. I believe that works, right? All you can do is using the transpose A or transpose B. For example, we can see, we can do it over here. So A is equal to, so A is equal to, we define A here, right? So 3, 5, 1, 0. And then we can see A prime is equal to 3, 5, 1, 0. 3, 5, 1, 0. And then 2, -2, 1, -1 is over there. Or we can use in the transpose, and you type in the transpose, and you will see it's come out, and then you get block and A. The same thing. So these two is showing the same thing. So you can use that one, and the RT method is transpose A. Okay, so either way you can do it. And same to the B. You all got this one, right? So we can use a prime sign over here to do the transpose. Same explanation here. Now next one we're going to do is the determine. Okay, determine. Determined. That is easy too. So you have a here. And again, make sure you need to have a square matrix or arrow. Okay, so we'll define a new A here is equal to 3 by 3, which is 2, 5, 6, semicolon, -1, 0, 5, second row, and then third row 3, 2, and 2. So this is 3 by 3, 1. And then we find A prime first, and then we find the B is a number is equal to the dt, which determinates matrix determinates of the A, right? And definitely we're interested in find C is equal to the determinant of A prime, right? So you see this one has two operations. So let's see how the results looks like. Oh, interesting. A is that one, and the A prime is that one, which is do the transpose 256 and switch 256, and we get a B determined here, and the C is a determinant of A prime. All right, so any questions so far?
I have a quick question.
Go ahead, yeah.
It's just, I guess I wasn't following this. How did you like add the like transpose and determine like text
Oh,
in the
yes.
middle?
So you can do it. So first of all, you will have two kinds of methods. So one is called script, one is called the leveling script, right? So I'm in the
Mhm.
lab script, and then
Mhm.
if I want to switch between the text and code, you can go into the new rows or the lines over here, and click this text.
Okay, thank you.
And you want to switch back to the code, you just click this code.
Okay, thank you.
Yeah, no problem. So that's the determinates. So once we know the determinates, and we're going to using our inversion, right? So again, we are using our A case, A here. We're just typing A here because we already defined A here, right? So same number, and we're going to call the B is equal to A inverse, right? We can type in that way is equal to INV, and you see the matrix inverse over here, and A. That should be giving our results very quickly. So section, run the section, and you see A is equal to this one, and then A inverse is a 3 by 3 matrix. You're getting same number as here. So because it has more information coming out, should be the same thing. Okay, so now we're going to try to see something. If A times A inverse is equal to I, right? So yes, we get it. So you can do it here. A times A inverse. So we run this section again. Yeah, we get an identity here. So that is I is equal to something. Oh, you don't really need to like detail like this way, but you can have this. Any questions so far? So we have learned the how to define a matrix. So first we need to define the matrix in MATLAB, right? So we have two ways. So one way is you can using the space. Second way is you can using the comma to separate the rows, and using the semicolon to separate the rows, right? Using the space all the comma to space the columns or the element in each one, right? So, and then we learn about the what we call is the here. This is the right? So we learn about the multiplication, and then we learn the transpose, and we learn about the determinates, and we learn about the inverse, and definitely this inverse is need to be a square arrows, right? So question so far? Yeah, I
No.
believe it's okay. Sounds good. I believe it's pretty easy, and since we're doing the Zoom here, it's much clearly than in the classroom doing when we see the PowerPoints, right? Okay, all right. So we did that one, and this is the identity matrix we're showing here. So let's try another example, right? So I see if this one has a inverse. So what we can do is we can pop up and see this is text and another example of inversion. How do we switch to code? So we get A is equal to block over here 3, 4, 1, semicolon 5, negative 2, 2, semicolon 6, 8, 2. Okay, this is what we call 3 by 3, right? So what we do is we can copy this one in back to this comma here, because if we not do this, we'll not retain your arrows coming up to here. So this is easy way. So we define A here, and we're getting A here. So can we find this one with an inverse? We can see, we just type in inverse INV and A, see what. So the matrix is singular to working positions, and the inverse we've returned is INF, which is no information over there. That means this matrix over here does not have an inverse. So again, we define our inverse is A times A inverse is equal to identity, right? But when we see the equation is 1 over the A determinant. So that probably is because the determinant of A is equal to, let's figure out, DET, right? A. So we see the DET of A is 0. That means this square matrix over here does not contain a inverse. It's because the DET of the A is equal to 0, right? So you can double check it over here. So it says DETA, and then you see the inverse A and what is retained. So so we process this section, and we see A is here, and the DETA is equal to 0, and then the inverse does not exist, right? So okay. So so far we have learned about that, and maybe we have something. Okay. So we repeat that one, we find out that one. So so this pretty much we learned about the matrix operations for right now. Let me see if any, okay. No, too much typing follow along with a small screen. So Demetrius, can you follow it? I don't have any downloads one because that's pretty simple. I can upload this one to the Converse later after we finish this class. Okay.
I didn't see like half of what you did because my computer is being weird. So like I'm kind of
Okay.
behind in the MATLAB.
Okay, so which one you are right now? So we
Like
just define
the first section, yeah.
here.
Yeah, I didn't get to the other sections because my computer was being weird.
Okay, I see, I see. So no worries, and take your time and to we finish this one. So kind of likely we all have is those. Okay.
Okay.
Yeah. So once you can save this one and this is our in class. November 24. So, okay, we just have a few topics left over here. And this is more related to the next chapter. Okay, chapter 8. Okay, yeah, for most of the time, we were dealing with the equation over here is kind of like a single equation. You have like the linear y is equal to ax plus b or something, right? And also, in most time we dealing the equation is like the nonlinear is more likely you will have a independent value and a dependable value, right? But we not really see anything other than the x over here, right? But if we have a linear equation like this way, 3x plus 4y minus 7d is equal to 19. And can we convert this one into a matrix format? For example, you put in the numbers 3, 4, and the -7 as a row, and the x, y, z as a column. And then the results you will see is 1 by 3 times with 3 by 1, and you will see that is a 1 by 1, right? So we can define a matrix to represent the equations. The reason we want to do this is later on, you will see you have you have three unknown variable over here. You want to solve the equation, you definitely need to have at least three equation over here to solve those questions, right? So we need to add in the second equation, 2x plus 3y plus 8z is equal to 14. And then definitely you just extracting those numbers before those variables and putting in the second row over here. And then you're getting results adding second row is 14 here, right? And if you have the third one, you do the same thing. You see here is missing a d. That means the d has the number over here or the factor over here is equal to 0. Right? You put in 0 here. So that is linear simultaneously equations. We going to mostly talking about how to use in this one for the chapter 8. So we were using matrix mathematics to solve the equations, right? And we kind of like using some of those in our previous chapters, which we call the 6, right? So the first step in the solving the series of linear similar equations is to writing them in a matrix format, right? for n dimension one, you will have n numbers of unknowns, right? So where A is the coefficient matrix, and X is the matrix of unknowns, like the X, Y, Z, right? So you are putting all those in a column, right? And the C is a constant matrix, which is n row, one column as well, right? So that's kind of the definitions over here. And recall that there are more unknowns than the equation, then we cannot find unique solutions, right? So if you only have two equations, three unknowns, then you cannot find it. But if you have more equations than the unknowns, for example, you have four equations and three unknowns, then you should be able to find it. And then the first one will be the redundant one, right? And if you are exactly the same number of the equation, and then you may be find a unique solution, right? But in some cases, you may not able to find it, right? So that kind of you at least have the same number of the equation as the same number of the unknowns, then you will be probably find out the unique solutions, and we can write this in the matrix format, A and a multiple with this X, which is unknowns in your column, and you're getting the C is a constant number in your column, right? A is this coefficient numbers. So let's take a look at this example over here. You have A, B, C, D, which is four unknowns, and then you have four equations. You have 7a plus 2b, and you can remove those c and d, which to negative c, negative d is equal to 3, right? So let's traverse this one first. So you're getting equation one is, I'm just in typing one, okay? So you're getting 7a plus 2b and minus c minus d, you're getting this equal to 3. So you're getting 0, 0, a plus 0, 0b. No, you have 5b. And minus and plus 0, c, and plus 2d is equal to 5. This is the second one, which is looks different, right? So you have a plus b and plus 3c and plus 3d is equal to 0. And then you have 2a minus b plus 4c and plus 0d is equal to 9. So can you convert all those four equations over here? Convert those equations over here into that, putting all the unknowns to the left side and putting all those constant numbers to the other side. You got the same number with me? Here it should be 1C, 1D, right? So if you want to see the difference. 7A, 2B, and negative 1C and negative 1D is equal to 3. 0A and 5B and 0C plus 2D is equal to 5. And 1A, 1B plus 3C plus 3D equal to 0, and 2A minus 1B and plus 4C and plus 0D is equal to 9. So this kind of like the moving the actual A, B, C, D to the side, and then moving the constant number 3, 5, and 0 and 9 to the right side. So okay, so we are prepared for this one, right? So now you can convert this one into a matrix vision. So you will see the coefficient, which is matrix here is CO. Let's get back to see what is COE, FICIENT, right? You have your coefficient matrix. Let's stick with here is equal to using the block over here. You're getting 7, 2, -1, and -1. This is your faster row, right? You're getting 0, 5, 0, 2 second row from your second equation. And then you're getting 1, 1, 3, 3 from your third equation, and then 2, -1, and 4, 0 in your fourth equation. So, and you're getting your unknowns is equal to A, B, C, D. Here should be careful because this you define like in this way is more likely a row. So you want to do this is you are getting is transpose, right? Transpose. Or you can say this is equal to A, B, C, D to separate different rows, right? But using this transpose will be better. Okay, so and then you have your constant numbers is equal to 3, 5, 0, and 9. And again, this is 1 is n by 1. It's not 1 by n, right? You have n rows, right? So you can do this is equal to 3, semicolon 5, 0, and 9. So any questions so far? How to convert your multiple equations with multiple unknowns into a matrix way? Okay, I can convert this one into code. And I can run this section. I get my code efficiency here. And is that one works out? No, because it does not recognize you have this, but this one should be worked out. Let's see. Yes, the cast number works out. So for here, the A, B, C, D is not being defined yet. So we want to using it as a variable. So okay. So any question so far?